And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. Congratulations on finding our channel, realizing its existence. And we're looking at the sun here in 193 angstroms from the Solar Dynamics Observatory. This ionized iron emission spectra is good at showing coronal holes. You can see the north and south pole coronal holes. There's also one around the equator. It's not very visible or well defined. It's North Pole oriented. We'll show you more on that later in the video. Here's the 171 angstroms. And we've got one sunspot. I think I might have said the wrong number yesterday. It's actually sunspot 2855, according to the Automated Integrated Space Weather Analysis Center. I try not to memorize sunspot numbers. It's not particularly relevant to much of anything. It's all but arbitrary. Anyway, only one sunspot and pretty weak levels of solar activity. Here's 304 angstroms ionized helium, which is good at showing filaments. You can see some filaments down there in a prominence feature in the southeast. And for you new viewers, we call this the east side of the sun because this is where space weather rises. And this is the west side of the sun because it's where space weather sets. When a sunspot finds its way to the edge of the limb, it loses its name and sets. That's why it's the west. It's a heliocentric coordinate system. Here's 171 and 304 angstroms together. One of my personal favorite composites. Let us know if you have a favorite composite from helioviewer.org. And we're always looking at different features with different wavelengths. The 10.7 centimeter radial flux has come up one solar flux unit to 74. Here's the 1 year chart of that to put it in context. And we're not expecting any space weather storms or anything like that. A whole lot of nothing going on in between us and the sun right now. We are expecting an uptick in the electron flux, which we'll get to toward the end of the video. You can find that data on the Space Weather Enthusiast dashboard. We saw one major earthquake here, a 7.1. or perhaps a 7.2. It's showing up here on the bar graph of the past 90 days from volcanodiscovery.com as 2 earthquakes, USGS listing it as 1. If it was 2, they occurred right around the same time. There's where they occurred. Southeast of the Philippines here, near Davao City. Probably caused some damage as it's showing up red on the pager. And we don't see any tsunamis, warnings, advisory, watches, or threats. So that's some good news. Any sort of tsunami warnings and so on have been canceled. Scrolling up the list of the rest of the earthquakes here on USGS, there was a 5.4 near Saipan also, quite far out in the western Pacific there. So that 7.1 came in yesterday at 1746 Universal Time, 5:45. Iceland saw 4.5. That one looks like it's actually pretty close to the volcanoes. Is it on the Reykjanes Peninsula? It's off the coast of the Reykjanes Peninsula. There's where that quake occurred. Again, a 4.5 magnitude on that. Some shaking going on in Hawaii. Fiji saw a 5.5 at over 500 kilometers. That would be like a 7 magnitude quake if it happened at the surface. That 5.5 at 517 kilometers estimated depth. Also some quakes off the coast of Oregon and Petrolia, California, both of small magnitude. Continuing on to volcanoes, we saw an uptick in the past couple of days. Let's see if it continues. Shivaluch exploding, producing a 17,000-foot ash plume over the Kamchatka Peninsula. And the other Kamchatka volcano not on the list. So Shivaluch on the list, and whatever the other one is, I don't remember the name, not on the list. Subanose-jima, flight level 070. It's a 7,000-foot ash plume over the Ryukyu Islands. Merapi, no volcanic ash discernible on image. Please don't assume it's not erupting over the Indonesian Isle of Central Java. Popocatépetl, still exploding, producing a 20,000-foot ash plume over central Mexico. Fuego exploding, 16,000-foot ash plume over Guatemala. Nevado del Ruiz, 19,000-foot ash plume produced via explosive activity over Colombia. Revenador exploding, 17,000-foot ash plume of flight level 170 over Ecuador. Sabancaya exploding 22,000-foot ash plume over Peru. Please don't pull Volta Caldera. Nevados de Chilean exploding. Flight level 120. It's a 12,000-foot plume of volcanic ash produced over central Chile. Again, please don't pull Volta Caldera. This public service message brought to you at massive personal risk and expense from smashamash.com. Because you're a smart viewer, however, there are a lot of dumb people, so remind them to not pull Volta Caldera. After all, they're not Steve Stimpak. And thanks everybody for watching the videos. Next, looking at the sun-facing suite of instruments on the GOES 16, the GOES X-ray flux showing only one minor B-class flare here, barely even relevant enough to mention. No spikes in the proton flux, no coronal mass ejections headed our way. Here's the GOES magnetometer over the past 3 days. Fairly smooth environment here as Earth is in a North Pole-oriented current sheet. So here's the polarity of the heliospheric current sheet. Green polarity is the north and red is the south. And Earth is solidly in that North Pole current sheet where we expect to remain for the foreseeable future. Also, I don't expect Sunspot 2855 to get bigger based on this magnetic data. This line of sight ecliptic plane field plot shows a three-dimensional view. So we can expect to see Sunspot 2855 degrade or maybe vanish entirely. I'm not expecting it to get bigger or grow additional umbrae at the moment. It's only an alpha-class sunspot. Likelihood of solar flare is pretty low. Here's your coronal hole line of sight plot. And you can see that trans-equatorial coronal hole just moving into the Earth-facing zone here, shown there in green. And we're seeing a surprisingly low number of trans-equatorial coronal holes that stretch over the solar equator. Anyway, here's the flare probability data as well as the detected sunspot groups. And you can find both of these on the Integrated Space Weather Analysis Center. Again, likelihood of major solar flares isn't really very high at all, as Sunspot 2855, seen here, only has one polarity umbra. KP index, a measurement of global geomagnetism, has been pegged at 1 for the past 24 hours. Global geomagnetic calm conditions. And let's take a look at the real-time solar wind to see if anything's been going on here. And we see the coronal hole wind stream subsiding, so we can expect an uptick in the electron flux coming here in the next 24 to 36 hours. Solar wind speed came all the way down from 473 to around 400 kilometers per second. So the current conditions are... Come on now. And this is a live applet, so it does have a tendency to be a little finicky. Current conditions are 3.81 protons per cubic centimeter for the solar wind density, a very diffuse solar wind. Solar wind speed nominal here at 410 kilometers per second. Nothing exciting going on there as the coronal hole wind stream subsides. Here's the magnetohydrodynamic pressure in the Earth environ here. It's our 4 hours of geospace magnetosphere movie. And we'll probably see the pressure actually reducing here in the past 4 hours. And maybe some gyrations. And you can forecast what this will look like by looking at the solar wind and vice versa, if you understand the physics. Anyway, that's 4 hours of data. Here are ground magnetic perturbations. Changes to Earth's own B field. This also gives you insight into the Earth's magnetic field location and the Earth's geomagnetic pole locations. It also gives you ideas of where aurora and power outages may happen as a result of solar storms. Nothing like that going on. Geomagnetic calm conditions. And like the last applet, this is 4 hours of data. By the way, again, thanks for viewing the videos. Congratulations on realizing the existence of our channel. Make sure you check our playlists at youtube.com/smashamash/playlists. Check out our awesome merch like our Mensa hat. And please join us in making Earth not suck again. Have you noticed Earth sucking lately? Well, I certainly have. So let's make it not suck again. It's up to you, not giant heaving bureaucracies that can't even get out of their own way. Yesterday we did our 2,000 subscriber special exclusive live stream, and it's in the playlist of weekly smAsho stream /anychat. So if you head to that playlist, you can find all of those videos by clicking on View Full Playlist. The most recent one is our 2,000 subscriber special. Check that out. It has remained on YouTube, where it will be an exclusive. And every week on Wednesday, we do a live stream. And yesterday's did include some cosmology talk. We talked about the movement on a galactic scale. Speaking of movement on a galactic scale, let's talk about movement on a planetary scale. Here's where stuff is located in the solar system currently. We'll advance this 1 week. There's where things will be on August 19th. As Earth swings past Jupiter and absolutely nothing happens. Did you know that if all the planets were aligned, it would create the gravitational equivalent of a ping pong ball on the Earth? Yeah, it's true. Next, the star chart here from in-the-sky.org. And we've actually drawn in the galactic plane as we did in yesterday's live stream. And if you're up before dawn, you may see Jupiter and Saturn. We've got the sun rising with Mercury trailing at the moment here in Lehigh Valley, Pennsylvania. 1, 2, 3, 4, 5. I've clicked on it about 80 times, and it's simply not. There it is. I've literally clicked on that about 100 times, and now it came up. Cheers. It's Mercury, right? Rising behind the sun. The true stars of the videos are our patrons. So thanks for being patrons. Increasing the probability these videos will continue to exist, remain publicly visible, and free for all to view. Patreon.com/smashamash if you'd like to help our cause. If you want to read about our mission, head to smashamash.com/forum/mission. You can find links on the homepage. Smashamash.org will redirect you there to smashamash.com. Check out our merch link as well. You can find the Mensa hat there. Also, subscribe over on Twitch. We've only got 97 followers. We're trying to get to 100. Today's cosmology segment will be ultra truncated, as we've got a nebula here, and what you're looking at there is that's hydrogen gas, the pink part, and the blue part is reflected light. The shadowy areas are the silhouettes of dust lanes in this Trifid Nebula. So the Trifid Nebula, located about 5,000 light years away, is today's astronomy picture of the day. If you want to go look at that yourself, it's apod.nasa.gov. apod.nasa.gov. The question is the imagery better than our merch? Don't answer that. Just go to smashamash.com and click on smAsho merch. Here's a quick view of the designs. Oh my God. Resistance is fertile. There's our forum, by the way. You can link to that also from the homepage. And don't forget to check our playlists as well. There are over 200 videos in the cosmology segment playlist. youtube.com/smashamash/playlists. Next, looking at the satellite charging environment, we don't see any charging hazards. This could be changing in the next couple of days as we're expecting an increase in the electron flux. Here's a 1-year chart of the relativistic electrons surrounding planet Earth. That's measured at the F ionosphere layer, located at about 300 kilometers of altitude. Here's the 3-day chart of the electron flux. Nothing to write home about there. It remains cratered here. As the coronal hole wind stream subsides, we can expect to see an uptick in this. And NOAA agrees. There's the forecast model. And that is enough to reach electron storm levels most likely. We could see some communications breakdowns as a result of that. We'll keep you posted. Here's a diagram of the Earth's Van Allen belts. There are the inner ones, and the location of the International Space Station just under the inner Van Allen belt. Distances are shown here in miles. Here's the total electron content, showing you electron density for the entire air column through both Van Allen belts. So this is actually different than the relativistic electrons we showed earlier. That's only at one layer, at the F ionosphere layer. This is the whole air column. And it gives you an idea of where GPS errors are likely to occur. We've actually tested this out with our own GPS, and indeed it is quite accurate. Fairly normal electron flux here in terms of the total air column. The total electron content forecast, one of my personal favorites. Next, a diagram of the atmosphere to show you where the F layer is. The F ionosphere is the next frame. Here's the ionogram for the past day. Some minor anomalies here in the southern Indian and Atlantic Oceans, but pretty mild. No major anomalies showing up here at all in the ionosphere. Everything looking pretty smooth up there. Again, that's about 300 kilometers of altitude. Here's the latest image from 11:15 Universal Time. Things looking normal there. Here's the anomaly graph, the anomaly ionogram, showing you the difference in percentage of megahertz. Oh, wait, that's percentage. That's raw percentage. We usually show megahertz. So let's just reload that. There we go. There's the anomaly animation, and I stand corrected. There are actually some anomalies here. Some low-frequency anomalies showing up there in all those reds. Indeed, down here in the southern Indian and Atlantic Oceans, really the Southern Ocean, as well as around the equator there, some low-frequency anomalies showing up in the ionosphere. So here's the latest image. Actually looking pretty anomalous there. Check it out. Some low-frequency anomalies, and again, I stand corrected. And we did do a meteorology segment today. Make sure you check that out. It's a separate video. We've got a playlist for that as well. It's got some pretty spectacular imagery, I might add. Next, bonus features. So here is the hydrogen alpha imagery from the Lurmonth, Australia ground-based solar observatory. We've got some major filaments here. You got filaments over here, filaments over here, filaments, filaments, and filaments. Lots of filaments. And we are not putting up a coronal mass ejection watch yet. We may do another video later in the day if we decide to put up a coronal mass ejection watch. We're in the pre-watch phase right now, if you're wondering. Here come more bonus features. It's the NASA GOES 16 SUVI imagery. And you can see all those orangish red regions there. Those are all filaments. Here's the latest refresh on the solar intensitygram, and you can see indeed Sunspot 2855 has degraded exactly as I forecast. It literally degraded while we did the show today. Here's the colorized magnetogram. Looking weak. Here comes some more images. We're going to do a shallow dive in 335 angstroms, another ionized iron emission state. It's part of the ultraviolet spectrum of electromagnetic radiation. Photons in a very specific frequency, 335 angstroms. So there's the full disk view. Let's get a little bit closer to the active region, the Plage and Sunspot 2855. Get a little closer, don't get burned. Get a little closer as the sun began to turn. And also we've got an even closer view. Great view of the coronal hole there in the North Pole as well. And here's the extreme close-up to close out the video. Once again, thanks viewers, thanks patrons, thanks everybody who picked up merch. Tell your friends and foes about the channel. Tell your science noobs and science pros about the channel. And may that solar wind be at your back. Daily Space Weather, a recurring feature at the Smash News Network. Least busted, name and news.